Alright everyone, you are welcome to the free JAMB Mark series for JAMB UTME 2026. Let's quickly head to the question without wasting most of our time. Ensure to make notes as you take this lecture. Ensure to make notes and do not forget to maximize your screen. Take this lecture on full screen by tapping on the icon located around this place that I'm hovering my mouse. The JAMB repeated question 1, it says, give the electronic configuration of element Z with atomic number 8. Element Z with atomic number 8. The second question here, JAMB repeated question 2, it says, the elements with electronic configuration 1s2, 2s2, 2p1 is a dash. A. Metal. B. Metalloid. C. Non-metal. D. Halogen. Then the third and the final question, still under the same electronic configuration. It says, which of the following is the electronic configuration of calcium? A, 1s2, 2s2, 2p2, and so on and so on. These are the options. They are all electronic configuration. So let's head straight into the technique of solving this JAMB problem, which is always repeated every year in JAMB UTME. So this is a free mark. If you know electronic configuration, you already have a free mark waiting for you in your JAMB UTME 2026. So let's head straight into the nitty-gritty. Electronic configuration. We are trying to learn what electronic configuration is and how to use it. Okay? Electronic configuration is the arrangement of electrons on the orbitals of an atom or molecule. The arrangement of electron on the orbital that's around the atom or the molecule. The arrangement of those electrons. You know, electrons are like charge. Electrons are charges located on the orbits. Okay, on the orbits of an atom or molecule. Okay, so the orbital or shells in this electronic configuration. The orbital of shells, we have 4 orbitals. You can call it orbital or you call it shells. Okay, 4 orbitals and shells. The first is s shell or s orbital, whichever you prefer. P shell or p orbital, whichever you prefer. D shell or d orbital, or whichever you prefer. Then f shell or f orbital. So using the SPDF electronic configuration, using the SPDF orbital or SPDF shell. So this is the subshell. Okay, there is also the main shell, which is the main shell of the atom itself, but this is the subshell used for electronic configuration, for the arrangement of electron on the orbit of an atom or a molecule. Okay, so take note of the color codings of each shell. Okay, take note of the color codings of each shell. Okay, moving on. The capacity of each shell. For you to find the electronic configuration of an atom or an element, you need to know how many electrons each of these orbitals or each of these shells can accommodate. The maximum electron that they can accommodate. So for the s shell, the maximum electron that it can accommodate is 2 electrons and below. That's the maximum is 2. So 2 and below. P shell or p orbital can only accommodate 6, not more than 6. 6 and below electrons. D orbitals, okay, can accommodate 10 electrons and below. F orbital can accommodate 14 electrons and below. So these are the maximum electrons that each of these orbitals or shells can accommodate. So it is important to know this. You need to learn this capacity, the capacity of each orbital or the capacity of each shell. You need to learn it. Okay, hope you are making notes, hope you are taking down notes. Okay, moving on. Having known the maximum capacity of each of the shell or orbital of the SPDF orbitals, each of them, we now know their electron capacity. What's next? Let's look at the steps of drawing an SPDF diagram. So this is the SPDF diagram. The steps for drawing SPDF diagram. Let's look at the steps. Ensure you are taking notes. Ensure you are writing as you are taking this lecture. Okay. 1. Put a heading, a top that's above. Just put a heading. SPDF. Okay. Label it SPDF. Just a top. SPDF. That's it. Okay. Then number 2, the second step. Put maximum electron capacity for each shell. Put maximum electron capacity for each shell. So after putting the SPDF atop of the page, then you put the maximum electron capacity of each of the shell. You put the maximum electron capacity of each of the shell. You put it under. S, you put 2. P, you put 6. D, you put 10. F, you put what? You put 14. Okay. Then number 3, the third step of drawing the SPDF diagram. Number it on the left side from top to bottom. For example, 1, 2, 3, 4, 5. So you are numbering it serially on the left side, just like the way these steps was numbered. Okay, just like the way these steps was numbered. Number 1, number 2, number 3, and so on and so forth. So just like the way these steps were numbered here, you number them 1, 2, 3 on the left side from top to bottom. Okay, you are numbering from top to bottom. So moving on. The next is the fourth step, which is impute each shell following the number sequence from top to bottom. Do one before the other. So you are going to impute each of the shells from top to bottom. Do one before the other. Don't do everything together. Do one. Finish S orbital. Then you go to P orbital. Then you go to D orbital. Then you go to F orbital. Then after that, you go to the fifth step, which is draw the direction of arrangement with an oblique arrow. This is an oblique arrow. You are drawing this line from right to left. Okay, so like this. An oblique arrow is like this. It's not straight. So you are drawing it from right to left. You are drawing it from what? From right to left. Not from left to right, from right to left. Oblique line. Let's illustrate what we have just learned. The first, remember what you have to do first? You write SPDF, giving space atop the page. That's on top of the page that you want to draw the diagram. You just write SPDF. Okay, so let's move over to the next. The second is putting the maximum number of electrons that each of this orbital can accommodate. Put it under. Let's see. So we just placed it here. The next, you put 2 and below. For S orbital is 2 and below. For P orbital is 6 and below. For D orbital is 10 and below. For F orbital is what? 14 and below. Having done this, the next is what? Use number serially on the left. You put the number on the left, as you can see here. Okay, 1, 2, 3, 4. Okay, then you number it serially from top to bottom. 1, 2, 3, 4, and so on and so forth, depending on the amount of the atomic number of the element. So the amount of the atomic number is going to determine how far you will go. So for first 20 elements, 1 to 4 is usually enough, and that's what they normally set in JAMB UTME. First 20 elements, they don't ask you to give any electronic configuration other than the electronic configuration of the first 20 elements, any of the first 20 elements. So they will not ask you transition elements. No, that's advanced chemistry. So at least 1 to 4 is usually okay most of the time. It's usually enough. Moving on, what's the next step? The next step is inputting. Okay, inputting each of the orbitals. Okay, input each of the orbitals following the number sequence. Okay, do it one before the other. What do I mean by doing it one before the other? You do S orbital first, you do P orbital second, you do D orbital third, you do F orbital next. So that's how you are going to do it. You are going to follow this number sequence as you are doing it. As you can see here, we numbered it here. Can you see? This to this, this to this, this to this, this to this. So 1S here, 2S following the number sequence, 3S, 4S. Can you see? Following the number sequence. We are going to do P, the orbital of P now. That's it. So if you notice something here, since P here is the next, which is P is the second orbital, we did not start it from number 1. We are starting it from the number 2 because it represents the second orbital. The second orbital starts from 2, so as the third orbital is going to start, okay? And so on, the fourth orbital is also going to start from 4, just like that. So we numbered it what? From 2, 2P, 3P, 4P, like that, just like so, okay? 2P, 3P, 4P. Remember, the second orbital, we start from number 2. Can you see? The first orbital is S, starting from 1 down to 4, or as long as it's going to be. Then P, okay, starts from 2 because it's the second orbital, taking it down, following the number sequence, 2P, 3P, 4P, and so on. Then for the D orbital, D is the third orbital, okay? And since it's the third orbital, it is going to start from 3. Let's look at it. Can you see? D starts from 3, following the number sequence, 3D, 4D, and so on and so forth. So D, we start from 3 because it's the third orbital. It's the third shell. So 3D, 4D, and so on. So let's do F. So where we F start from? You got it right. So F we start from 4 because F is the what? The fourth orbital. Okay, your number starting from 4. 4F down and so on and so forth, depending on the atomic number of the elements. Like I said before, 1 to 4 is usually enough for the first 20 elements. And JAMB will not set any element other than the first 20 elements for you in JAMB UTME. So I don't think you need to do more than 4. Okay, I don't think you need to do more than 4 serially. Okay, so let's look at F. F starts from 4, which is 4F. Okay, 4F. Okay, can you see? So with this, we are almost done with the what? The SPDF diagram. So what is the final thing to do? The final thing to do is representing the flow or the direction of the what? The arrangement with an oblique arrow. An oblique arrow like this, from right to left. Remember, it goes like this, like this, like this. Not a straight arrow, but an oblique arrow. Let's look at it. These are the oblique arrows. Can you see? The oblique arrow. For 1, obliquely. For 2, you need to do it in an oblique way. Any of the orbital that enters the line enters the line. Anyone that does not enter the line, do not bend the line for it to enter. So it is very important. This is the most important aspect of drawing the SPDF diagram. Because if you mistake here, or you commit any blunder around this place, or you fail to draw this oblique line perfectly, the way it's supposed to be, you are going to get a wrong arrangement. Okay, so you have to draw it down to 1S, to 3, to 4, just oblique. The first one is to 2, yes. The second one is to 3. The fourth one is to 4. The fifth one is to 5. The sixth one is to 6, just like that. You are going to use this serial number as a guide. Remember, the first oblique line will not touch number 1, but the first oblique line will touch number 2 obliquely, not straight, not transverse, but oblique. The first one we touch 2, the second one we touch 3, the third one we touch 4, the fourth one we point to 5 or we touch 5, and so on and so forth, just like that. This oblique line guides us when we start picking from these orbitals, okay? From these orbitals, from this arrangement, it guides us because we are going to pick. You can look at it, you can see the direction, okay? The direction of the arrow is telling us that you pick from right to left. So from the first line, you are going to pick from here, from right to left. So what do we have there? 1s. The next one we have here is here, the second oblique line. Only what we have there is 2s, and we are supposed to pick from right to left, okay? The third one, what do we have there? The third oblique line, what do we have there? 2p. We are picking from right to left. 2p, then before we take 3s, and so on and so forth. Moving on. Before you start answering any question, read and understand the instruction first. You can see the instruction is color-coded in red to tell you that instructions are dangerous in examination. If you don't read your instruction, you are going to fail. So read and understand your instruction first before you start answering. That's being smart, okay? So let's practicalize this electronic configuration using the SPDF orbital diagram. Going back to the JAMB repeated question 1, it said, give the electronic configuration of element Z with atomic number 8. Element Z, we don't know the name of the element. It was named element Z here, but the atomic number is 8. If you know the elements that have the atomic number 8, you already know this element Z. So let's look at the answer. First of all, determine the Z with the atomic number. Like I said before, as we know the atomic number of the element, we can find the element. So the element with the atomic number 8 is what? Oxygen. So element Z is oxygen. Moving on, the next thing is to draw the SPDF diagram. The SPDF diagram, we already know how to draw the SPDF diagram. So we are going to use the SPDF diagram to find the electronic configuration of element Z, which is oxygen. What do we have here? The first thing we have here, or the first arrangement we have here is 1s. Okay, look at it. The first oblique line, 1s. Remember, we are picking from right to left, right to left. So we have 1s. And how many number of electron can the s orbital or the s shell accommodate? Or how many number of electron is the maximum capacity of the s shell? Is 2. So we are going to have 1s2. Let's look at it. Can you see? 1s2. And remember, these 2, these exponents, these 2, this raised in power we have here, these 2, represents the atomic number. Okay, so we are going to continue with this raised to power or raised in power exponents until we exhaust the atomic number of the element completely, and then we are done with the electronic configuration of the element Z, which is oxygen. So since we have 1s2, now is 2 up to the atomic number of the element? No, meaning that there is more to this 1s2. So let's move over to the next arrangement. So we are going to pick the next from the next oblique line. The first oblique line has been exhausted. We only have 1s there. So we are moving over to the second oblique line, which is this, okay? So we only have 2s there, and it's still in the s orbital. And remember, the s orbital can accommodate how many electrons? 2 electrons and below. So we are going to pick 2s, and what are we going to put as an exponent? 2, because it can accommodate only what? 2. Let's look at it. Can you see? 2s2. When we calculate the exponents, when we sum them up, plus them, is it still up to the atomic number of the element Z, which is oxygen? No, it's not. So what do we have to do next? We have to continue what? Putting more orbital arrangements, okay? So let's look at the next that we are going to pick. Here we have 4, okay? 4, that's what we have here. What we have here, what you can see right here, is the electronic configuration of any element that the atomic number is 4. 2 plus 2, 4. And which element is the atomic number 4? Beryllium. Okay, so this is the electronic configuration of beryllium element, beryllium. So we have to continue for us to completely get the electronic configuration of oxygen or element Z, which is oxygen, because this is the electronic configuration of the element beryllium. So moving on, let's pick the next. So the next we have here, we have exhausted the second oblique line. Let's move on to the third oblique line. Remember, we are picking from right to left, okay? So the third is, we have 2p there. Okay, 2p, that's what we have first. So we are going to pick 2p. Remember, how many electron? Remember, the 2p is in the p orbital, okay, or the p shell. So how many electron is the maximum electron that the p shell can accommodate? Is 6. So the maximum electron that we can put here is 6. Remember, the electrons represent the atomic number. Let's put it 2p Why did we put 4? Because if we put 6 here, it's going to be more than the atomic number of oxygen, which is 8. So we put 4 to complete it. When you plus what we have here, 2 plus 2, that's 4, plus 4, that's 8. So this is the electronic configuration of the element Z, which is oxygen. But if we put 6 here as the maximum electron that the p orbital can take at a given time, it's going to be an electronic configuration of another element, which is the element that the atomic number is 10. What element's atomic number is 10? Neon. So the element neon has the atomic number 10. So if we put 6 here, for example, this electronic configuration becomes the electronic configuration of neon, the element neon. So for us to get the electronic configuration of oxygen not to exceed the atomic number, remember all these exponents, all this raising power represents the electron, and the electron represents what? The atomic number. This is what you are going to plus to know if you have exceeded or you have reached. But you have to follow the proper sequence, which is 1s, 2s, the next one, 2p, and so on and so forth. The oblique line guides us in doing this, okay, to know the right orbital to pick at a given time. So this is the electronic configuration of the element oxygen, element Z. Electronic configuration of oxygen is 1s2, 2s2, 2p4. Thus, the above is the electronic configuration of element Z, oxygen. It's easy, so easy. This is a bonus mark in your JAMB UTME 2026. So you've gotten that one. You have a bonus mark, a free mark waiting for you in JAMB UTME 2026. So let's look at other patterns that JAMB can set this electronic configuration question in. Moving back to the question reads, give the electronic configuration of element Z with atomic number 8. So we already figured out element Z, we know it's oxygen, and the atomic number is 8. And this is the electronic configuration. This is our answer. This is the final answer. So just look at the option carefully and pick the option that matches this particular electronic configuration we have here. So moving on. Electronic configuration of oxygen, 1s2, 2s2, 2p4. Note something very important in this electronic configuration of oxygen. The exponents represent the atomic number of the elements. Like I said before, all this raising power you have here. The sum of these exponents represents the atomic number. So if you plus them up, you are going to discover that it's 8. Moving on to the next question. Question 2 says, the element with the electronic configuration 1s2, 2s2, 2p1 is a dash. The element with the electronic configuration 1s2, 2s2, 2p1 is a dash. Can you see another pattern at which JAMB sets questions from electronic configuration? So what are we supposed to do here? Remember, we just said that the exponents, all these raising powers you are seeing here, okay, the sum is the atomic number. So the first thing we have to do here is to plus all the exponents we have here, all the raising powers we have here. Let's plus it. 2 plus 2 is 4. So plus 1, that's 5. So the answer says, since the sum of the exponents, the raising power, represents atomic number, add all exponents. So we have add all the exponents and we got what? 5. 2 plus 1 equal to 5. So atomic number is equal to what? 5. We now know the atomic number, which is what? 5. We know the atomic number of the element. So the big question now is, what element has the atomic number 5? Hydrogen, helium, lithium, beryllium, boron. The answer is boron. Boron has the atomic number 5. So what next are we going to do? What group does boron belong? Boron belongs to group 13, also called the what? The boron group or the boron family. Okay? Boron is a what? Boron is a metalloid. Boron is a what? Metalloid. It belongs to the group 13. Remember the common metalloids we have. What are metalloids? Metalloids are elements that behave or that have both the properties of metal and non-metal. Okay, they possess the properties of metal and non-metal. So that's why they are called metalloids. So boron is a metalloid. Okay, boron is a perfect candidate for that. So boron possesses both the properties of metals and non-metals. Okay, so we also have other metalloids such as silicon. Silicon is a metalloid, and germanium, and so on and so forth. So let's go back to the question. It says the element with the electronic configuration 1s2, 2s2, 2p1 is a dash. A, metal. B, metalloid. C, non-metal. D, halogen. What's the answer? The answer is metalloid. That's the answer. Let's move on to the next question. JAMB repeated question 3 says, which of the following is the electronic configuration of calcium? Which of the following is the electronic configuration of calcium? A, 1s2 blah blah blah, B, 1s2 blah blah blah, C, 1s2 blah blah blah, D, 1s2 blah blah blah. Let's look at the answer. How are we going to attend to this question? Another pattern of questions set from electronic configuration. Let's look at the answer. The solution. First of all, determine the atomic number of calcium. What is the atomic number of calcium? The atomic number of calcium is equal to 20, which is 20. Calcium is the last element among the first 20 elements. Having figured out the atomic number of calcium, we are going to check for the option that the sum of the exponents or the sum of the raising power is 20. Remember, the sum of the raised in power or the exponents in an electronic configuration represents the atomic number of the atom or the element. So let's look at the sum. So among the options, let's sum each of the exponents or the raised in powers. Option A, 2 plus 2 is 4. 4 plus 1 is 5. Is 5 equal to 20, which is atomic number of calcium? No. Option B, 2 plus 4 is 6. 6 plus 1 is 7. Is 7 the atomic number of calcium? 20? No. Option C, 2 plus 2 is 4. 4 plus 6 is 10. Is 10 the atomic number of calcium? No. Then option D, 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 6 is 18. 18 plus 2 is 20. Is 20 the atomic number of calcium? Yes. This is the answer. So you can now pick the answer, the electronic configuration of calcium. Okay? Which is what? D. The sum of the exponent or raised in power matches the atomic number of calcium. D is the answer. So there is another consideration you have to make in such a question, and let's look at that consideration. You have to be very careful. To confirm the option, check if the arrangement is correct. Remember the normal arrangement we spoke about, the sequence, okay? And what is the sequence? The sequence in the SPD diagram, following the oblique line from right to left, following that oblique line from right to left, okay? Check if the arrangement is correct. To save time, because you are in an exam condition, I am going to give you another method of checking it in a faster way, okay? A faster method of checking if the arrangement is correct. To save time, only do this when you have more than one options with the same sum of exponent. So when you are at risk of choosing the wrong option, you just have to do what? Just look at the other exponents. If you have only one option that matches the atomic number of the element, you are good to go. So you pick that option. But if you have more than one option with the same sum of exponents of that element or of the atomic number of that element, what do you have to do? You have to start checking, okay? You following the oblique line. You check from right to left, ensure that it follows the sequence. All right, moving on. This is the orbital diagram. So we have to look if it follows the sequence, which is 1s, 2s, the next 2p, tracing down, following the oblique line, 3s, then we go back again to the next oblique line, 3p, 4s. That's that for that. I think it ended here, 4s, the electronic configuration of calcium. So let's head back to the JAMB repeated question 3. It says, which of the following is the electronic configuration of calcium? A, blah, blah, blah. B, 1s, blah, blah, blah. C, 1s2, blah, blah, blah. D. So all these options are wrong, wrong, wrong. The correct option. Much for taking this lecture. Free bonus mark in JAMB UTME. And I hope that you understood the lecture, you enjoyed the lecture, and you've learned a very, very important aspect in chemistry that is going to help you in your JAMB UTME 2026. You already have this free mark secured because JAMB repeats this electronic configuration every year. So you already have this mark secured. Ensure to continue practicing and ensure to read your notes, revise your notes, the notes you made in this lecture. And do not forget to drop a like on this video if this video is helpful to you. Share this video to your friends. Subscribe to this channel. Follow for more at Nkwado Augustine across all social media platforms. Do you have any questions or knowledge gap, or do you have any topic that you want me to discuss? Drop it on the comment section and I am going to respond to them accordingly as soon as I come across your questions or recommended topic. At this point, I'm out.